Hello. We're just waiting for more people to come in before we get started today. All right. So I'm Chushin, and today I'm going to lead the Blockchain Data 101 workshop, segment 4. And today we'll be covering Dune analytics as well as focusing mostly on like writing SQL queries in Dune V2 query engine. So if you've never used Dune Analytics before, it is one of the popular kind of like blockchain analytics um, data tools that a lot of people use and share on Twitter. And there's right now two versions running on Dune at the moment, so V1 and V2, and I'm going to explain the difference between V1 and V2. And in today's workshop, we're going to focus mostly on querying in V2. So I prepared this kind of Dune dashboard for everyone to have a look at after the workshop, but we'll go through each of them as well as doing live demo as well. So it's not just about staring at the screen and looking at the written SQL queries. But first of all, what are the differences between Dune V1 and V2? The first difference is they're using different SQL language. In V1, it's mostly using like PostgreSQL. And right now in V2 is using the Databricks SQL. So it is a few different, like some minimal differences between the SQL syntax, which will demonstrate not all of them, but some of them in the demo. But here is a very good summary in the Dune docs about the SQL differences. So you can use them to have a reference, and this will keep updating when like other contributors come in and kind of like specify these are the differences. A few things that I come across from time to time is basically I think in Dune V1 you do so addresses like the wallet addresses or transaction hashes are in the byte. It's kind of in the bytecode, so the data type is byte T, and it's usually like a slash, so replacing the 0 with the rest of the string. Sorry, not the string, but the byte T. However, in V2, it's actually a string, so you can just copy and paste it from Etherscan, but since everything is in lowercase, so you have to do like lower the wallet address or any other hashes. So we're going to kind of like talk through that later on. And then, so it's like a very nice kind of summary in terms of how you're going to translate your V1 query into V2. So that's one of the differences. The other difference is, so since there are two different databases, the V2 version is actually more column oriented instead of row oriented. And I'll explain that very quickly. Back to the doc. So there's a very long kind of paragraph about what is row oriented and what is column oriented. And what I get, my takeaway from this is that, so imagine your database is like a book, and whenever you want to query the data, you have to, oh yeah, sure. looks clear now. Yep. So yeah, basically imagine this is a book, and then whenever you want to query it, you are flipping to a page. And normally they store the data as in terms of maybe hundreds of thousands of rows together in one page, and you use that as your like page header. So every time when you query, say, row 500 to 600, you flip to that page, and then here it is. So that's like more row oriented. And if you query rows, like continuous rows, it will be much faster. But if you want to query discrete rows, for example, like page 5, page 99, and then page, I don't know, 1,000, 1 million, then it's going to be slower. So that's the drawback of this like row-oriented database. And the new V2 engine is column-oriented. So that means you're going to have columns as one of the page header, and then you also have different rows stored. So that means it's very good for computing aggregation stuff. For example, you want to do, I don't know, sum or group some columns and then group by. It's actually much faster compared to the V1 version. We will go through some examples of that to see the differences as well. But yeah, that's basically what is a row-oriented versus a column-oriented. And when you do queries, you have to kind of keep that in mind, especially in V2, because normally what I see people doing is that whenever they come to doing data analysis or exploratory analysis, the first thing they would do is find out the table and do select star from. And if you do that in V2, sometimes it's going to take really long, depending on what table you're querying from. For example, if you do Ethereum transactions, if you do select stuff from limit 100, it's going to take ages, and there's ways that you can make it run faster. So we're going to jump into the demo now by doing a very simple select star, and then we'll see how it goes. So I have two tabs open right now. The first one, so this is a Dune interface where you can switch from different chains. And then here specifically, this one is V2. So right now I'm in V1 Ethereum, and they actually look exactly the same. So this is V1, and then this is just V2 that I switched to it. But yeah, we're going to do a very simple query right now. And the one I'm going to use is, so let's quickly inspect a transaction on Etherscan. So here is a example transaction hash that I've got. And this is a very simple one, which is just transferring from Coinbase centralized exchange to a wallet with like 102 ASX. So that's the XE Infinity token. And that's a very simple transaction. So what we're going to do here is first, we want to pull this out from Dune. And all you need to do is just, so this is V1 right now. I'm going to take a note and just to make sure I also remember. So all you need to do is just select from Ethereum.transactions where the hash equals this. And remember, because it's in V1 right now, we have to change this to the slash. So I guess like this is kind of turning this into a byte data type. And then you just do select stuff from, which is easy. And we hit run. Boom, it's out. So it takes 0 seconds and we get everything we want about this transaction. And I'm just going to do the same in V2. I'll progress from here. So the first thing that I mentioned is that because this one turns into a string now and everything is in lowercase, so what we need to do is, yeah, hash equals lower, and let's see how long it's going to take here. So first of all, it's taking more than 0 seconds, which is not ideal because I think people have been talking about why is it so slow? Yes, it is. That's because it's not row oriented, and also it's not indexed. It's not indexed on transaction hashes. So what we want to do here is actually providing more conditions. We want to, so I guess what we know, what we know here is that we have block number, which is, so block number is actually ordered. It has min and max. Same applies to block timestamp. We know that is like on, I don't know, like 296 days ago. But the block number as well as the block time, because they are ordered and we have min and max number. So it's kind of similar to a binary search where you know the smallest number and the biggest number, and then if you provide, say, the block time, I sort of can do the search. So it's in between min and max. Let's start from 50, and then we go from, I don't know, between 0 and 50, and then in between that. So that's sort of how it works. And so here I'm gonna just quickly provide this block number here to make it run faster because it's ready after a minute. Let's cancel this. And we hit run again. Ideally, it should be faster, but let's see. Oh, why is this still taking? Yeah, I think I do. Yeah, okay. So I think last time when I ran this, it actually took 3 seconds, but 10 seconds is still much better than, yeah, more than 1 minute. So as you can see, if you're doing queries in Dune v2, especially looking at those like big tables, remember you probably want to provide either a time filter or whatever filter that applies to a column that has order. Yeah, so when you do select stuff from this Ethereum transactions, you probably want to kind of specify, or maybe block number greater than something, and then you do limit 100. Otherwise, it's gonna take forever and probably get timed out. So yeah, this is a very quick demo of yeah, like the query time. But now we want to go a little bit deeper. So I guess what we want to do is we want to kind of pull out the information from a Ethereum transaction. Oh yes, I'm surprised that it doesn't just zooming everywhere. But yeah, this is the Ethereum transaction we're talking about. And we want to pull out, say, for example, we want to get the from, we want to get the to address. We want to also get the ERC20 token transferred as well from Ethereum.transaction table. And this is how we're going to do it. So I'm going to demo that in V1 first, and then we do that in V2. So we'll kind of do like switching between the tabs, but after that we'll be mostly focusing on V2 just not to confuse people. So yeah, there's a few differences. So if you are actually querying something that is also using the same syntax as the SQL language, mostly what you want to do is you have this like quotation mark in V1. Excuse me. So what we want to get is, yeah, just nicely block time from to I forgot. So you don't have to use the quotation thing all the time. It's mostly just for uppercase columns and also any kind of column name that is similar to the syntax of the SQL language, for example, like from. So we get these columns as well as value. So the value here is actually the ETH value. And in this transaction, it actually has no ETH value, is 0. And then we also want to get the gas use. So the gas use is, sorry, not the gas use, but the gas price. So gas price is on layer 1 is just gas use times the gas price divided by 1 to the power of 18. So this is, yeah, 1 to the power of 18 as gas price ETH. What else do we want? So I'm going to quickly introduce a function, but what we want to get is, so let's quickly look at the data here. So this is the data from this transaction. And normally for the first, I think for the first 8 byte here, so other than the /x, so this part is actually called the method method ID or maybe the function signature, and usually you can use that to actually map to another table to understand what this method ID or function signature is. And I guess if you look at it here, that's exactly the same as what we see in the data part. So this is the method ID, and if you are familiar with it, so this is just a transfer. It's a transfer function call basically, and we want to get that from the data as well as the ERC20. So as well as the amount of the ASX token amount, which is also like embedded in the data here. So as you can see, this is a transfer. This is to address. So we're gonna transfer to this address basically. Yeah. So we transfer to this address, and this hash is the value. And if you click decode input data, normally it will just show that if your contract is actually decoded. So how are we going to do it here? We're gonna use this substring. I guess before we use the substring, I think we have to encode the data first. So this, yeah, because this data is byte right now, we can't do substring. Substring only applies to a string, and it's not the string right now. So we're gonna do encode data and then hex. So this will basically turn the whole thing into a string, and then we do substring. So substring, and we want to get the first 8. So I think when it turns into, so when we do the encode, it will leave out this /x thing, and what we want is actually just the first 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so yeah, basically you get the first 8 of the string. So this is substring, and you take starting from 1 and you get 8 up to position 8. Yeah, and this will be as the method ID. And now we also want to get the amount of token transferred. So it's very similar to what we did above. I'm just gonna quickly copy and paste. But now the tricky thing is I want to know where do I start and where do I end. So normally how it works is that I think each of the hashes, let me quickly see it. Switch back. I didn't count it, but I just know it. Not that I just know it, but just, yeah, like learn it from experience. But basically this is around 64 characters. So what we do here is, I know the ERC20 thing. So this amount is the very last bit, and that's 64. And this one is also 64. So a little bit of math here, but basically what we have is, so that's gonna be 8 plus 64. So I'm just gonna quickly say that. So 8 plus 64. So 8 is the first method ID. The other 64 is the address, and we're gonna start from here. So that's what, 72. But because normally we start from position 1, so it's gonna be 72 plus another 1, and that's gonna be 73, and then we get 64 characters. Let's see how it works. I think it should be working. And that will, so this is gonna grab, I think, the last bits of the 64 characters, and we want to turn it into a number. So the really nice function created by the Dune team, so it's called, I think it's byte to numeric, and we're gonna turn this into an actual number. And I guess, oh, but we have to, yeah, this is a little bit complicated, but yeah, before we do byte to numeric, we still have to decode it back. I think there's actually a function that helps you to do all this stuff that I'm doing right now, but yeah, I guess let me quickly recap. So what we've been doing here is we first kind of convert this into a string, convert this data thing, and then we get the last 64 characters from here. And then we have to sort of decode it back into a byte again. And then we do byte to numeric. So we turn this into an actual numeric. And let's see how it goes. I'm gonna just divide that by 1 to the power of 10 to the power of 18 again. And we call this, I don't know, ERC20 amount, I guess, token amount. Oh. Yeah, sure. Give me a second. I'll just quickly hit run. And so the purpose of doing this is, first of all, assume that you actually don't have an ERC20 transfer table, and you actually want to decode certain blockchain data in terms of what's happening in this transaction. So yeah, as you can see from the result here, we get the basic ones that we don't have to do anything complex. We get the gas price. We also get the method ID. So we know this is a transfer function signature, and this is the token amount that actually got transferred in this transaction at least. So it doesn't show up, it doesn't directly show up here because there's no ETH transferred in the value. So that's why you have to do all this like complex kind of decode encode thing to actually get the token amount. So yeah, like the reason I kind of demonstrated here is because I think it's useful when it comes to, sometimes when it comes to like just querying the data from raw blockchain kind of, yeah, transactions. So yeah. Does that answer the question? I mean, there's definitely an easier way of doing things, but kind of like start the hard way. So basically, I know that here is just transferring ERC20 data, and there's actually a way of in Dune that you can do it easily instead of doing this encode decode thing. So what you can do is actually, I think there's a table called ERC20 transfer something. I always don't remember the name of this. And then, and then all you have to do is just get the same hash. Oh, why is it not showing up? I think it is. This. So this has everything that is related to ERC20 transfer, and we're just using the same hash. And this is what the table is about. So contract address, block number, from, to, and a value. And if we hit run, oh, it's not tx hash, it's evt tx hash event. And we hit run. And that's going to show up the same thing. And this is the value that we get out of here. Yes. Yes, that's what we're trying to do. But yeah, you don't have to do it all the time. It's just a way of showing it. I think sometimes it's useful if I guess your contract is not like properly decoded, or there's more information to get out of, say, logs or traces. But I think now, because there's such table exists, you can actually just use them. But I'm gonna quickly, how to calculate the amount. Oh yes. So let's get back to this quickly. So I think for each of this, so for example, this transfer function, for all the method ID is gonna be 0x plus another 8 characters. So we know this is, yeah, 8 of them. And then once this thing finishes, the rest will start with lots of zeros, but then this thing is 64 characters as well as this. So if you have a very complex function and you have, I don't know, multiple different inputs here, it's all going to be like, for each of them, it's all going to be like 64 characters in the data. And that's this. So this input data here is the same as the data in this transaction. So what we do is, so I know I want to get the last bit, and that's 64 characters. So but I want to know, where do I start from? So where do I start from is, first, method ID is about, so that's 8 of them. So I start with 8, but I'm not starting from 8, because if I start from 8 and get 64, that is actually kind of getting this part. So I want to skip this, which is also 64 characters. So that's going to be 8 plus 64. And we'll start from 1. So that's going to be 1 plus 8 plus 64. So that's how we get 73, which is here. And so when it does the substring, it's going to start from the 73rd character, and it will go for, and it's going to end at 73 plus 64. Yeah, I hope that explains. So okay, cool. So I'm now gonna quickly copy this thing, and then we do this again in V2 and see what the differences are in terms of syntax. So first of all, you have to change all this into a slightly different, this is, how do we call this? But yeah, something different. It's not a quotation mark anymore. But yeah, normally you don't have to do it all the time. This is just for demonstration purposes, which makes it look very tedious, but you don't have to do it all the time. So let me just quickly change a few things here. So hash, let's do lower, and then we change it to 0. Another thing we do is, remember, it's gonna take a long time. So I'm gonna set the block number as well. That's one of the differences. And now, let's see. So these are all the same, which is simple. You don't even have to change this, which is nice. I guess one thing we have to do is, so we no longer have to do this encode decode thing anymore, because the data now in Ethereum.transactions in V2 is actually just a string. So yeah, like previously, the whole point I was doing all this encode decode thing is because it's not a string, and we have to sort of turn this into a string so that I can do substring. And if you see it now, the type, so you can see the data type here, which is just a string. So remove, so this can all be removed. But one thing to note here is that because it's a string, so the 0x is also part of the whole string. So instead of doing 8 characters, we have to add the 2 0x as well. So it's going to be turned into 10. But I think you can also remove them if you don't want the 0x, because it's the same everywhere. But here, I'm just going to keep it. And then what else? This thing can also be removed now. I'm gonna quickly, so I'm gonna remove this bit. This is no longer needed. This is also no longer needed. Doing lots of delete, change. And yeah, so if you got what I was talking about previously about how I arrive at 73, now because of the 0x as well, just add 2 here, sorry. So that's going to be 73 plus the 0x to 2 characters. So it's going to be started from 75 instead. And yeah, so as you can see, we remove everything about the encode decode of hexes, and we just do a substring. And then also in V2, so if you see the doc, right? previously when I was doing this demo, I was thinking, oh, so where's this byte to numeric function equivalent in V2? And they have this. I tried it, it doesn't work. So I searched on the Dune Discord, and they actually have a byte to numeric V2, and you don't have to worry about this at all. I think I'm going to submit a PR to update the doc here, but what you do is just change this to V2 as well, and then I think it should work with the same thing. I got queued, but yeah, I think normally it should run, and this is V2. So as you can see, here are certain syntax differences in terms of using this quotation mark thing. And then also in terms of how you get the method ID, you're gonna use a different byte to numeric v2. But then after that, and also set more where conditions here. And then after that, you're gonna get the same result as what we did in v1. Yeah, having no idea why I got queued. Maybe just too many people doing the query. Oh, why did I get queued? Oh, yeah. The reason that V2 is organized so differently. So yeah, I think fundamentally is the database different. As I mentioned before, one is PostgreSQL, the other one is Databricks SQL. So it's just like slightly different SQL kind of syntax thing. And if you use Flipside Crypto quite a lot, they are using Snowflake. So that's also different. But I think fundamentally it's still select stuff from and doing all the SQL stuff. It's just the syntax, if that's what you're asking for, like in terms of why it's organized so differently. Or maybe there's something else. Yeah, but if that's what you're asking, then that's my answer. But if you want to know more, or maybe that's okay, cool. Yeah, actually I don't know why I get queued, which is bad. So while I'm getting queued, let's just keep going. So in the dashboard I'm gonna share later, here is actually what I was doing just now. And this is just like a side-by-side comparison of what the difference is, and you get the query. So now the second bit is we want to kind of utilize what Dune has compromised for. So basically is column oriented. And what does that even mean? Like, so if when we do select star from a hash, it's taking slightly longer than V1, why do we even bother moving to a V2? And this is what V2 is actually better at doing. So what we're going to do is we're going to do some aggregation here, looking at Ethereum transactions and users, as well as average, like basically calculating a lot of things. The amount of gas used, median, average, and then the gas price as well. And we want to aggregate it across maybe since from 2020 May. So that's what I did for V2 at least. And then we'll also do the same in V1 and see how much slower and also how much longer it's going to take. And apparently this one got timed out already. So this is why I did in V1. And that's the same, like underlying data is all the same. And this is why I did in V2. It still got run. So yeah, let's do it. I'm going to cancel this quickly if it doesn't run. I'll try it again. So I'm since we're doing V2, right? So maybe let's do the query first in V2, and then we do in V1 and see how long it's gonna take. Or is it just my internet? It's actually slow everywhere. Cool. So yeah, basically we want to have a high level summary of Ethereum transactions since 2020 May. And we are using V2 right now. So I'm not going to use any of those quotation marks anymore, just because I'm lazy. But yeah, first thing is we want to get it maybe on what time interval. So I'm going to quickly introduce something nice. So for example, right now I can't decide what kind of time interval I want to do. So let's use something called parameter. And that will solve the problem. So basically I'll let other people or the end user to decide what kind of date truncation they want. So I'm just call this time interval. And I'm gonna do block time as date time. So here is very nice that you can just specify. So I'm gonna create a list just to make people's life easier. Week, month, year, and I'll set day as default, or maybe week as default. Yeah, so if I hit run, this will compile the this bit here into week. And if you switch it from something else, it will be month, year, whatever. It just makes the end user experience nice. And sometimes as like a data person, you also have to think about who's actually looking at the dashboard or who's using it. How can we make people's life easier as well? So yeah, and now what we do is a few things. We want to get the number of transactions, which is actually quite easy. So you just need to count the hash as number of transactions, and then count. I also want to count how many active addresses there are. So let's count distinct from as number of addresses. And then we want to know the total amount of gas used. So that's a sum of gas used, as well as the average gas use. So yeah, let's do a lot of computation and aggregation here. Average gas used. What else we want? Maybe not the median. Don't want to bother the median anymore. And also the average gas price. Average gas price. Is that all? Yeah. Yeah, let's try it first. And then if we want to add additional things, then we add. And then group by 1. Another thing is where I want to set it to block. So I think what I did in my example is I set the block number to greater than 1,000,000. I'm just going to quickly copy this. So it's going to be greater than all these blocks, and then group by. And I guess I also want to add, I'll quickly explain that later. So yeah, I think so if you look at Ethereum transactions, there is success, which is a Boolean. So I just want to get the transactions that didn't fail. So I put a success here. And also I set the block time just to make sure things is actually running. Otherwise it's going to take ages if I query this amount of data that we have. And now we're just going to hit run. It's going to be bad if everything I have is, it's not queued anymore. So yeah, while it's running, we're going to do the same in V1 just to kind of compare the query time. And I think the rest is actually the same. Oh, this is bad. But so I'm just going to comment everything out. And let's see if I need to change anything. I don't think so, other than this. And I also need to get the same value. Gonna copy and paste from here. Change it to week, save. And then I think I hit run too. Yeah. So while we are waiting, block number doesn't exist. Oh, I'm kind of switching between different tabs right now. So while we're waiting for this two aggregation queries to run, let me quickly fix what's happening here. The block number, is it not called block number? It is. Did I do anything wrong here? Block number doesn't exist, but it's there. Actually, let me just try again and see. Oh, did I spell it wrongly? Oh, yes. Thank you. Thank you. Couldn't tell the difference. But yeah. So yeah, they're all running at the moment. This one is probably going to take longer. This one probably will finish around 5 to 6 minutes. But yeah, we're basically querying the data of Ethereum from 2020 May, and yeah, that's gonna take a while. So maybe let's take a quick question. Yeah, if anyone has any questions, or we can kind of continue while all the queries are running. Nice. So if there's no questions, let's so after the query finishes, oh, there's a question. What's the difference between average and median? Yeah, so average is kind of like, oh yeah. I was like, average is just getting average across all the numbers. But yeah, I'll probably start from median first. So median is getting, so if you have, I don't know, a list of numbers from 1 to 100, you have like 1, 2, 3, 4 up to 100, and you want to get the median. So median is, as we can see here, median is 50. So median is just getting the 50. So basically just getting, if you have a number of like from 0 to 100, you're pretty much getting the middle number out of this ordered list, and that's going to be 50. So that's the median. And if you have more of the numbers, say like to 1 million, then the median is going to be 500K. But the average is going to be like an average across all those numbers. So if you want to know the average between 1 to 100, you add all of them up. So 1 plus everything up to 100 and divide it by 100, and you probably won't get 50. Yeah. And I hope that explains. Is it asking me the difference between average and median, or how? Yeah, I hope I'm getting the questions right. And so yeah, and while we're waiting, so once the query finishes running, we can actually do some charts to make things look nicer and see how we do visualization in Dune as well. Next question, how can we find the correct table for analysis? For example, we have prepared tables for platform. How can we trust each one on how to? Yeah, so I guess the way I do it is, first of all, you have to think about, so if you actually know what the platform or the protocol or the dApp that you're looking for, normally you can check whether those protocols have been decoded. So yeah, there's a lot of things here, as you can see. And what I normally do is either, for example, I want to look at something about Aave, I just like search for Aave and see what's coming out here. So for example, I think here is, yeah, we have Aave on Ethereum and Optimism. Aave Gochi is not what I'm looking for. And also like Aave V1 and V2. And these are actually all the decoded contracts of Aave. So for example, these are all like the different, I don't know, functions and events, like all this landing pool and stuff. And then depends on what you're looking for. For example, maybe this landing pool is about like getting the borrowing and supplying thing. So for example, if you want to look at, oh, I want to know like all this historical records of RV borrowings, and you probably can check what's in this table. So it's a little bit of like trial and error sometimes, unless you are super familiar with the protocol by itself. And then here, for example, this is also my first time looking into them, but I'm guessing that this borrow event thing has all the records of the borrower records. And what I normally do is I'll just like select stuff from limit by 100, but also remember to limit by whatever block time or block number. And then I'll just inspect the transaction hash and see what's happening here exactly on Etherscan, just to try to understand, is that something that I'm looking for? And I think that applies to all the other different protocols as well. So I think, yeah, as a data person doing like on-chain analytics, sometimes you also have to like, understand the analysis that you're doing, the protocols that you're looking into, just familiarize yourself with that. Sometimes even spend doing a few transactions to understand what kind of event or what kind of function get called. And then you can start like kind of doing it. But so that's one way of doing that if nobody has done the analysis before. And also the other way of doing it is, you search on existing dashboard that exists on Dune and see how other people do it. Not necessarily all the time that the way other people do things is going to be 100% correct, but that also helps you to kind of find out the right table, kind of looking at the queries that people do, maybe the logic as well. I hope that answers the question. I think there was another question that I didn't see. Okay, since okay, this one finishes, I'll just quickly wrap this one up. But basically, this is the V2 of querying the same transaction hashes, and we have the method ID, we have the token amount. This 0x can also be truncated if we want to. But yeah, that's how it works. Now back to this aggregation. So this is the V2 aggregation that we just did. And it finishes around 4 minutes while the other one is still running. So let's quickly do some charts. And this is the data that we pulled out just now. So we have the date time starting from block number 1,000,000, and then block time, the time is 2020 in May. And we have all this like nicely aggregated, summarized data about transactions, addresses, gas use, etc. So I'm gonna quickly do 2 visualizations, I guess. So one is, I guess we do one that is gas related, have a bar chart. So yeah, this is actually transactions, but I want to change it to gas use. So this is the total amount of unit, whatever unit that gas is. So this is the total gas use, and we want to also plot something side by side. We want to have the average gas use as, I think we would just, maybe average gas use. Let's have it. So average gas use, and because the average gas use is much smaller than the total gas, so they are on completely different scales, and we want to change that because nobody's going to understand what's happening here. So what we do is, first of all, I want to change it to a line chart, and then also I want to enable the right axis. Enable the right axis and then change this to the right axis as well. So it's going to look like this. Left axis is the total gas, and then the right is the average gas. And we also want to kind of make the label format looks nicer, because previously is lots of decimals, and we change it into something like this to make it look much more human readable. And then I think right now I know left is total and then right is average, but I think the end user probably wouldn't know. So in order to just be more user friendly, I will just total gas. and the other one is average gas. And looks much nicer now. And you can also title it, I don't know, Ethereum gas used or something like that. And then you can save it and add to your dashboard. So normally what you do is, oh yeah, because I haven't saved it, but you save it and then you can add it to whatever dashboard that you're looking for. So this is how you kind of like do a quick bar chart here. Yeah, so do I want to do another one? Probably not, they're the same. So yeah, you can also just add number of transactions and addresses in a similar way as well. And I'll quickly go back to what I've done here. So this is what I did. So that's transactions and users. And you can also change how the legend is looking like as well, because normally the legend would just reflect the column name. And sometimes the column name is like something, something underscore, which doesn't look nice. But yeah, this is all just decorative things. But it will actually set you apart from a lot of other data visualizations already. But yeah, so this is what I've been talking about, like why is it much faster in terms of doing all these aggregations, and took 5 minutes. And this one is still running in V1 because first of all, a lot of data, and then also V1 is not optimized for this. Tell the advantage of being a Dune wizard. I probably wouldn't say like there's an advantage of like either using Dune or Flipside or anything. Normally, so I got to start using Dune just because I started a course last year and I got introduced to Dune first. But I think normally you should try not to kind of like constrain yourself in terms of, oh, I'm only going to use Dune, or I'm only going to use Flipside or something else, but more just like whatever tools that provide you with the data you want and helps you with your analysis, then you're just going to use that. Yeah, like from time to time, I also use different other tools as well, just because sometimes, for example, if you're querying like, I don't know, harmony or near, like those data doesn't exist on Dune, and you want to do that. So you go to Flipside. And yeah, like if you want to do something else that only exists in certain platforms, or maybe even do analysis that is not available on Dune or Flipside, or maybe you want to do some, I don't know, like Python or R, then you probably just have to set up your local instance and do things like either locally or on the cloud. So yeah, I think it really depends. But I think it would be nice that when you first get started, if you're not familiar with all this like data toolings or blockchain stuff, just stick with one and join one community. So here, trying to be pretty much like platform neutral, so you can choose whichever you prefer. And I'm pretty sure if you're doing a great job, you will thrive anywhere. So yeah, that that would be my answer to the question. So yeah, I'll probably not gonna keep running this to waste the resources, but this is gonna take ages. I'm gonna quickly cancel that, and we move on to I guess I'll go to the last bit of using Dune abstractions. And there's actually another thing towards the end, but we probably don't have time to go through it. So I'm gonna share the link to the dashboard later on, so anyone can actually come back and see what I've done here, and then also play around by forking it or whatever. But yeah, last bit I'm going to talk about today is actually using Dune abstractions. So previously, all the examples we've done is actually just using either raw blockchain data or maybe sometimes decoded contracts, which I actually haven't done there. But you might wonder, what is abstractions? Or abstraction is, yeah, table, basically, but it's custom table that a lot of other Dune wizards curate them. So it's very similar to like all this like fact table, dim table in Flipside as well. That you don't have to worry about doing all this hash encoding, decoding. You don't have to do all this like stuff in order to get the number you want. And usually Dune abstractions is organized in two different ways. So one is sector related. For example, there is abstractions that is like NFT trades, DEX trades, lending, stable coins. So all these tables are representing a sector. And you don't, so for example, traditionally, if you want to do, I want to get the entire NFT market and see how the market share is across OpenSea, across LooksRare, and even looking at Solana, you probably have to go through all of them and aggregate them together manually by yourself in your SQL query, which is very tedious and also going to take a long time and repetitive as well. So imagine every single person doing that. That's just lots of work. So what NFT Trace does is having this like nicely aggregated summary of different marketplaces, and you don't have to worry about how do I combine them, how do I find a contract, etc. So right now, I don't think NFT Trace exists in V2, but these are on V1, and I think the Dune team has been working on getting those nicely curated abstractions into V2. But there's also something that exists. For example, this OpenSea Seaport contract that I'm going to talk about. So we will get, so what we want to get the end result is basically we want to know the top NFT collections by volume in the last 7 days. And then we're going to use this this abstraction to get those, which is so much more similar to the traditional way we do query the data table rather than decoding contracts. Maybe I'll just close. I'll just reuse this. So let's have a look at the abstraction first. So it's actually broken down into like raw table, decoded projects, abstractions. So I'm going to have a look at Seaport. And they have, excuse me, they have one table which is called view transactions. And as you can see from here, they have the traditional like block number, block time, the buyer, the category, contracts, whatever ERC standard, and exchange addresses, the fee they received, what is the NFT project all about. So yeah, as you can see, you won't be able to get this kind of nicely curated data directly from the blockchain. But with the help from the community and also other people, you can actually get them very easily. And that's gonna make all of our life much more simpler. So I'm gonna quickly have a look. So what we want to achieve for the end goal is to get the top collections by volume. So let's get started. Select from, if you are lazy typing out the name, you can just click here as well. And then what's here? Last 7 days. So I'm gonna do some filter first, where the block time is greater than now, minus interval 7 days. So this is gonna specify it's only the last 7 days. What else do I need? Maybe, so we're gonna use USD amount, and there's a column called USD amount here. Where's USD? Not the fee. Wait, I can't see the USD amount. Oh, here. Just do a little bit of USD amount is not none. Sorry, it's greater than 0. And also, I think additional thing I want is this project name is not null. Cool. And what else we need? So we want to know that by collection. So we probably need something like NFT project name. NFT project name. What else? Oh, maybe also know the number of transactions as well. So that's going to be, I think it's the TX hash. Get the number of transactions as number of transactions, and also sum the USD amount as volume. So yeah, that's pretty easy. So you can just get them very easily if there's like always going to be this nicely curated table. And you can also order by 3, which is volume USD, and just hit run. So yeah, what this table is gonna create is an NFT project by volume, ordered by volume from, oh, I forgot to do descending. Yeah, but it's gonna give me that in descending order to see which one is the highest and which one is the smallest. Actually in my example, in the dashboard, I also create like a hyperlink for the project name. So when you click the name, there's gonna show you the contract of the NFT project on Etherscan as well. But I'm not gonna go through here just because we are almost running out of time. But I also want to quickly demonstrate something else that is kind of like showing the power of Dune queries in V2 as well, which is you can actually do some kind of, I would say, cross-chain analysis. But so here is actually a example of comparing the daily fees across Magic Eden, LooksRare, and OpenSea. So instead of writing everything out, I'm just gonna quickly walk through what I've done here. So click that. So as you can see, I actually utilize, so I take advantage of 2 of the abstractions that people created. So one is called magiceden.fees, and if you see from here abstractions, you can actually, I'm just gonna search. So here Magic Eden is a project. They actually have a fee table which shows you aggregator address, the name, the block number, blah blah blah, everything, as well as the platform fee, I think in USD as well. So what I got is just get the day, get the project, which is Magic Eden, and then the fee. And I limit the time to greater than June 15th, just because I think that's when OpenSea launched the Seaport new contract. And then I'll do the same for Seaport as well. So that's the OpenSea one, and it's very nice and easy. You also just do daytime, project, and sum, and I union them together. So I created this CTE, like common table expression, called OpenSea Magic Eden, and I just union them together. When you do union, just remember everything should be the same in terms of column name and also the order of the columns as well. So once that's unioned, now I need to do the same for LooksRare, but LooksRare actually doesn't have any abstractions. So nobody has helped me to prepare this kind of like LooksRare fees or whatever LooksRare view transaction nicely. Then what I'm gonna do? So the thing I did was actually find out the transaction on LooksRare, for example, this one. So yeah, that's what I mentioned, like, oh, how do we do stuff when nobody has curated the tables for us? For example, this is a LooksRare transaction that I found, which is transfer like an ENS from this wallet to the other wallet of the token. So there's only one token got transferred for 0.038 WETH. And then what we want is actually find out what the fees LooksRare as a platform get. So as you can see here, the total amount, and this is what the seller's gonna get, 0.03724. And this is actually the fee that LooksRare as a platform get. So basically what we want to do here is we want to get this number. And I was trying to look at LooksRare decoded contracts to find out the fees, but I couldn't find it. So if that's the case, now I have to come back to, yeah, pretty much decoding, not this, but basically decoding some of the logs to get this number. And if you click the logs, right, so there's a few things happening here. But yeah, don't worry about all this deposit right now, because I know I'm going to find out the transfer, because I want to know what is the fee that actually got transferred from from actually got transferred to LooksRare account. So here, if I transfer, there's a few transfers happening here. So one transfer is this is actually the fee that we want to get. And then there's also another transfer. This is transferring whatever amount deducted by the fee to the seller. And there's also another transfer. I think it doesn't really emit anything. So what we want to get is out of Ethereum logs, we want to get this transfer with this amount. So that is actually the transfer fee. And that will apply to all the rest of the LooksRare transactions, unless they upgrade the contract. But I think the transfer is always going to remain the same, unless they change the address or something. So here is the transfer topic, I think. So yeah, as you can see, the transfer also having the same topic. And so this is topic 1 address, and so from address to address and the raw amount. So this is what we're trying to do. Let me go back to it. So once we understand what's happening in the Ethereum logs, what I've been doing here is Ethereum the logs, we want to get so actually before we get into this, so what I did previously is before you even try to query the whole kind of transaction records, because we have this example transaction hash. So what I did was, let's just look at what's happening in this transaction hash in the Ethereum log and see if I'm actually getting the data that I want. So what I did is just having set this and get this transaction, which we can probably quickly show it here. So instead of having all this thing here right now, let's quickly run that and see what it does. Even comment this out as well. So yeah, let's have a look. Oh, another queued. But yeah, so I think basically this is gonna pull out all the 5 logs that we are seeing here. But as I mentioned previously, we just need the transfer. So we have to specify a few things, basically saying, oh, this topic is gonna be this hash. And then we also want to know, so this is the wallet that they transfer the fee to. So I'm gonna specify this as well. So that's what I've done here. Topic 1 equals the hashes that I highlighted just now. And then I also want to get the address that got transferred to. Oh yeah. I know what's happening because I didn't do alias. So let me quickly have a look. Oh yeah. So this is the address that is going to transfer to as for the LooksRare platform fees, and then also want to specify the contract address, which is the WETH contract address, and that's how you kind of grab all the fees from LooksRare. So once this finishes, we can have a look, but once that's done, you can get the fee original number. And then we get the prices. So we want to convert it into USD because for OpenSea and Magic Eden, someone else have already done that for us. So what we do is we want to get the WETH fees from this prices.usd. Once you get the WETH USD prices, you just need to join price table and this fee table together to convert that into USD. And this is what I was doing here. So you join them based on daytime and then get the price in USD and union everything together. So this is the LooksRare thing that we did just now in Ethereum logs, and then just union that with the OpenSea and Magic Eden number. And then we will get the bar chart, like the stacked bar chart that I showed you previously. And that's it. Yeah. So let me just quickly pause for any questions. No, I think at the moment you won't be able to do them just because first of all they're using completely different databases, and also there are two. Oh, are you saying you want to combine a query that you run in Dune and a query that you run in Flipside together? Yes, still the answer is still no, just because first of all the tables are named differently and probably the structure are different as well. So yeah, I don't think there's any way of doing them. You can sort of like translate. So for example, if you're querying the Ethereum transactions on Flipside and you want to copy and paste that into Dune, you can, but you probably have to change first the table name and then maybe the column name and yeah, and other stuff. Yeah. I think the underlying data will be the same, for example, for Ethereum transactions and logs and everything, but just the way they are curated or formatted as in terms of columns is different, so you can't really do that. Any other questions? I'm going to comment this one out. Okay, cool. I'm just gonna quickly revert this back, and then because right now nothing is showing up here anymore. But yeah, what I did previously is, yeah, this is a transaction that I just looked at on LooksRare with the ENS token sale, and these are the logs. So as you can see, there's multiple different logs from different contract addresses. I think this is the WETH. This is the WETH address. Yes. So what I did is, yeah, let's grab the WETH contract address, grab the topic one that is related to a transfer, and then also topic 3, which is the address that it transferred to, which is this address that I want, that is going to a LooksRare, whatever treasury address, I suppose. And then once you get them, you also have to decode this data here, apparently. So that's what I was talking about, like previously, about the decoding, and then you get the fee. So waiting for someone to nicely organize that for LooksRare in V2, so we don't have to do that anymore. But yeah, I think that's I guess we will probably wrap up here. And there's also a nice, before we finish this live stream, there's also, so we pretty much gone through everything that I want to cover for today. And there's also like a very nice thing about extra cross-chain analysis I want to do. So this is a simplified version of like how much fee you could save on Optimism fee calculator. And this will kind of like demonstrate you what the L1 and L2 fee differences are. And this will also combine everything that we learned today. And feel free to play around, fork those queries. And yeah, we also host an office hour on Friday Eastern time as well. So yeah, if you have any more questions, feel free to come to the office hour and I'll be there. I guess that's all for today. Oh, thank you.